Greetings YouTubers, this video is part 3 in a series investigating the fuel efficiency of pot burner systems. And if you haven't seen the first 2 videos, I recommend starting at the beginning as each installment builds upon concepts introduced previously. Part 1 looked into the performance of various combinations of burner size and pot diameter and flame level in order to see what the most efficient setup might look like. It also measured the differences between heating with and without a lid. Part 2 then reconsidered these conclusions in the presence of wind at increasing speeds. And wind obviously introduces efficiency losses with heating. So in this video, I investigate how much performance might be salvaged by the addition of a third-party windscreen. And so how many extra boils might you get out of a gas canister when it's windy just by dangling one of these around your pot? And of course, the question that's always on Graham's mind, how many grams of fuel can be saved, and is it enough to justify the extra weight of a windscreen? There was a bit of a learning curve in the proper use of a windscreen, so stick with me and I'll lead you down this latest of rabbit holes. My methodology is described in detail in parts 1 and 2, but as a quick reminder, all testing is done inside my shop, which is climate controlled within the range of 48 to 50 degrees. So air movement was supplied by a Vornado 723 DC fan and calibrated by a Kestrel 1000 wind speed meter marked with settings for 1 through 7 miles per hour. Water temperature is taken by probe accurate to a 1/10 of a degree, while weights are measured on a scientific scale and repeatable to 1/100th of a gram. Timing is done by hand using the stopwatch app on my phone. For this round of tests, I conducted some duplicate trials to check my accuracy and ended up with results that were 0.07 grams of each other, which is fine enough to observe even very subtle differences in performance. So in regards to the selection of windscreens for these tests, just 2 quick reminders. First, I have no sponsorships or relationships with anybody for anything at all. I buy all my own gear at full price. There's no free stuff, no discounts or deals of any kind. And also, I'm not attempting to do product reviews per se. I couldn't possibly test everything out there. There's a lot that goes into one of these videos, and this one's been months in the making. So instead, I've chosen just a few types based on their designs to see if we can glean some insight into the principles involved. John over at Flat Cat Gear has a nice variety of options to choose from, and his designs tend to be stove specific, and he's got windscreen models that support several different brands. And that includes, from parts 1 and 2, our old friend the BRS 3000T. Well, I figured a screen that used the lightest burner on the market would stand the best chance of being able to meet that elusive worth its weight criterion. So I picked the Ocelot Mini BRS for the first round of tests to set a baseline for future comparison. And the design is elegant in its simplicity. You get 3 pins that poke through the existing holes in the stove support arms and a titanium foil screen that wraps around to tab into itself and then slide down over the pins. Installed, it's stable even in high winds. Taken apart, the whole thing nests inside a pot. And altogether, the parts weigh less than 24 grams. The included instructions say to set the flame level at about 1/3 full power for best fuel economy. And as a reminder, all my tests have been run at one of 3 different flame levels. I mount the stove to be tested on an MSR low-down remote adapter, which has its own valve. And I use 3 different adapters, so each one can be set to its own level, low, medium, or high. As an approximation of John's recommendation for about 1/3 full power, I used the adapter for my low flame setting. And one last reminder about methodology. I use a water volume of 415 milliliters for each boil. It fits comfortably in a 1/2 liter pot. It is enough to prepare pretty much any 2-serving backpacking meal out there. And by boil, I mean heated to 200 degrees. That's more than needed to pasteurize, and it's hot enough to rehydrate meals or make a nice cup of cocoa without unnecessary fuel waste. So here are the results for a BRS stove on low, outfitted with an Ocelot Mini windscreen using a Toaks 550 pot and lid. The graph shows you the grams of fuel used per each one of my proprietary boils at increasing wind speeds. And you can see that as the wind gets stronger, there's a fairly steady increase in the amount of fuel required to reach the set water temperature. Now compare the windscreen results to the performance of a bare stove. The notoriously susceptible BRS is already becoming impractical at about 2 miles per hour by itself, but the Ocelot Mini keeps it boiling for significantly longer. The windscreen performance at 5 miles per hour was still better than bare at 2. An unprotected BRS on low would simply be unusable at wind speeds this high. It's hard to put a value on the added weight of a screen when you are comparing its efficiency against not being able to use your stove at all. Now recall from part 1 that a low flame is generally more efficient than a medium one, as is medium to high. And from part 2 we saw that as wind speed increases, a low flame can start to be overcome. And at some point it becomes more efficient to up the flame level to medium. A stronger flame resists being blown off the pot, which wastes fuel and robs you of efficiency. And where that efficiency turnover occurs can be different depending on the circumstances. So compiling the previous data on wind performance, we can make a sort of efficiency profile for how to properly use a given stovepot system. So here you see the Ocelot Mini's low flame performance against an efficiency profile of a bare BRS. And as always, my convention is to display low flame values as blue bars, medium is in green, and high is shown in orange. So with an undressed BRS, a low flame is best from 0 to 1 mile per hour. And at 2 miles per hour, you're better off increasing to medium. And at 3, you'll need to set it to high. So without having to switch back and forth between different graphs, this shows you the correct flame levels and fuel consumption numbers for how to operate a BRS most efficiently across varying wind speeds. And comparing that here to the Ocelot Mini's low flame results, you can see by how much it outperforms an unadorned BRS at any level. When the air was completely still, there was effectively no difference between screen and no screen. There apparently isn't enough cradling of heat around the pot to save a measurable amount of fuel in that way. As soon as the air starts to move, however, there's an immediate advantage to having a screen. And at 1 mile per hour, you'll be saving just about 2 grams of fuel per boil by using an Ocelot Mini over a naked BRS. You'll also get about 15 boils per 110 gram fuel canister. So over that canister life of 15 boils, at almost 2 grams of savings per boil, you're ahead by 29.4 grams of fuel weight. The complete Ocelot Mini is only 23.86 grams, so already it's worth its own weight in fuel savings. True, 5.5 grams isn't something you're likely to notice, but as usual, Angry Gray Shirt Guy is missing the point. You also get 3 extra boils out of a small canister, plus the arguably priceless ability to keep using the stove in conditions you otherwise would simply not be able to. And all of these advantages come with no effective weight penalty because you're technically saving more grams than the windscreen costs you. This is just how I view the problem, but that to me is the point. So just for comparison, I've put in a bar for the MSR Pocket Rocket Deluxe at 5 miles per hour. The PRD is well regarded for its wind resistance, but even on high, it's using almost 16 grams of fuel per boil. So just by wrapping an Ocelot Mini around the humble BRS, you get something that's significantly more efficient than the Pocket Rocket Deluxe and at a fraction of the weight. The PRD by itself weighs just over 80 grams, so BRS plus an Ocelot Mini weighs only 48 grams. And they're cheaper. When was the last time in the world of backpacking gear that you could get better performance at a lighter weight for less money? Right, moving on. Knowing there is an efficiency transition with flame levels as wind speed increases, I wanted to see if and where that transition occurs when a screen is in use. So I ran the Ocelot Mini through another test series, this time using a medium flame and taking it all the way up to 7 miles per hour, which is a pretty stiff wind. And here are those results. The performance on low was a fairly uniform ramp. On medium, though, you can clearly see this peculiar curve where the fuel use increases rapidly at first, and then seems to all but pause in the middle before starting to pick up a bit near the end. Now, I'm going full speculation here, so take this for what's worth, but it occurs to me that there are at least a couple of key concerns with windscreen design and use. One is flame displacement, same as with the bare stove. As the wind speed increases, the flame gets blown off the pot and heat is lost. To combat this, windscreens protect the flame from this flow. Keep in mind, however, that a flame needs oxygen to burn, and that which restricts airflow can also restrict oxygen supply. The oxygen supply problem could be aggravated by flame level. In other words, it might not show up when the flame is set to low because oxygen consumption is also relatively low. Turn the flame up, however, and the demand for oxygen and therefore airflow increases. So in a case where oxygen supply is having trouble meeting flame demand, a little breeze might be a boon. And everybody knows that blowing on your campfire will make it glow brighter. Well, normally this isn't an issue for the open flame of a canister stove system. Wrap that flame in a flow restricting screen, however, and a bit of blow might boost the glow. In a nutshell, that's what I think you're seeing here with these curved results. that show up so clearly with a medium flame but essentially disappear on low. An oxygen-deprived flame gets initially displaced by the onset of movement, but as the airflow increases, oxygen supply does too. So one is hurting efficiency while the other is helping. Countervailing effects again. The better fed burn helps to slow the usual spike in fuel use brought on by an increase in wind speed. And it's not enough to actually improve efficiency, but it seems to almost compensate as fuel use barely climbs despite wind speed increases from 3 to 4 and even 5 miles per hour. And at some point, the flame is adequately oxygenated and additional wind just means more displacement away from the surface you're trying to heat. And at 6 miles per hour, we start to see fuel use climbing more rapidly again. So I have two forms of corroboration for this oxygen starvation theory. You can actually smell the difference between the exhaust of a well-fed flame and a hungry one. And they add stink to the gas for safety reasons, so you can detect a leak. Well, when the burn isn't quite complete, it gives the fumes a distinctly metallic tang, and if you sit downwind, you'll know something isn't right. Also, soot's a well-known byproduct of incomplete combustion, and during some of my tests, the usually immaculate pot bottom was visibly stained with a small patch of brownish soot. I never have these things happen with a bare stove, an indication that windscreens can, in some uses, create an oxygenation problem as an unfortunate side effect of wind protection. So from part 2, we saw that as wind speed increases, there's eventually a turnover point at which a medium flame becomes more efficient than a low one. For a bare BRS stove, that turnover was at 2 miles per hour. Well, I wanted to see how a windscreen might affect that, so I ran the BRS and Ocelot Mini all the way up to 7 miles per hour on both low and medium flame. And here are those results side by side. As you can see, the windscreen keeps a low flame as the most efficient level all the way up to 6 miles per hour, where medium finally becomes the cheaper option. And here are some flame shots of the Ocelot Mini setup on low at 2 and 5 miles per hour and medium at 7 miles per hour. When it comes to windscreens, there are a lot of unique designs out there, and I wanted to try out a few different styles. So for my next round of tests, I acquired an Optimus clip-on windshield. It's a half-wrap design with a bottom that leaves the backside entirely open. I picked up mine from Amazon. And since the shield clips onto the neck of the fuel canister itself, it can technically be used with any stove that will fit inside its arc. For comparison purposes, I kept things consistent with the BRS. And here are the results on low, still using the same Tox 550 pot with lid on. Not very different from the Ocelot Mini actually. Here are the two windscreens side by side. As you can see, it's the same general slope. They seem to be neck and neck, each taking turns at being slightly ahead. And I guess you could call it a tie, but for the differences in their physical form. Now think of it this way. Suppose that I started with the Optimus and then said, now give me a design that saves just as much fuel, but I want it collapsible and shrunk down small enough to fit inside this pot. And I want it to weigh less than a third of what this clunker does. You might have been inclined to say that probably can't be done. Over at Flat Cat, John said, here you go. And some flame shots of the Optimus on low at 2, 5, and 7 miles per hour. Another very interesting approach is the SimmerShield, which is sold as a complete system. It comes with a BRS burner, a 650 ml cup and lid, the shield wall, plus a floor, all of which is titanium, and a 2-part cozy for the pot. The cozy is split because you're supposed to use the cap to cover the pot part while you're cooking. To assemble, you slot the floor around the base of your burner. You fold it into a sort of bowl and tab it together. The shield wall actually clings to the sides of your pot using the spring tension of all these perforated tabs along the top. You put it on by sliding it down over the top and popping it past the lip of your pot. It can then be adjusted to height as desired. Now, I did not use the cozy cap during testing for 2 reasons. First, with the cozy in place, there's no way for me to insert my temperature probe. But more importantly, I wanted to see the performance of the windscreen by itself for best comparison to the other models being tested. It could be argued that you could always add some sort of cozy to the other designs as well. Also, I noticed that the SimmerShield's included pot was the same diameter as Toke's 550, so I used that instead to keep one more thing consistent between the trials. The SimmerShield has a performance page on their site where they discuss everything from weight to boil time to fuel efficiency. And I started running the SimmerShield through my windspeed test series. The numbers looked good until all of a sudden at 2 miles per hour the fuel use jumped significantly. And compare this to the Ocelot Mini's relatively steady increase. The Simmer's 2 mile per hour performance was almost as bad as the Ocelot's 5 mile per hour number. I could tell there was a problem right away. And you can see and hear the flame sputtering and faltering dramatically and only partially recovering. And this was repeatable too. I've done it 4 times with the same result. So here are flame shots of the SimmerShield on low, starting with no wind, and then 1 mile per hour, and then the sudden difference at 2 miles per hour. So rather than simply being starved to death, it also looked like the flame was being battered about and at times almost snuffed out. And every time I tried it, the bottom of the pot ended up looking like this. It can be tempting to envision the airflow around a cylinder as something like the picture here. This kind of smooth streamline is known as a laminar flow. It only occurs, however, at low Reynolds numbers. In this case, R is only 1.54. When in fluid mechanics, a Reynolds number is the ratio between inertial and viscous forces. It varies depending on the circumstances, but a general rule is that a Reynolds number is greater than 3500, the flow is turbulent. So what kind of flow is there likely to be with the air pouring around a windscreen? Quick and dirty with an online calculator using the kinematic viscosity for air at the temperature of my shop and about 2 miles per hour wind and a 4-inch windscreen, you get a Reynolds number over 6,300. So instead of that nice laminar flow, you're getting turbulence similar to this. Now these vortices on the leeward side can create negative pressure. And the implications are uncertain, but it seems plausible that this turbulence might enter the burn chamber from the rear through something like a cutout in the back of a windscreen. And it's also possible that the curved profile of the floor acts a bit like an inverted airfoil, creating downward lift below the pot. So watch again at the flame struggling in a 2 mile per hour wind. You see how blue flames keep spurting downward out around the bottom edge of the windscreen? And here it is again looking at the front or windward side of the screen. And that flame really wants to rise, and it takes a pretty significant counterflow to make it spill out the bottom like that. Now, I did not see such downward flame spill with the Ocelot Mini, even at high speeds. We're above my pay grade at this point, but on a hunch, I tried it again without the floor. Much better this time. No spike at 2 miles per hour, and it made it all the way to 7 miles per hour. Here's a side-by-side look, both at 2 miles per hour on low, of the SimmerShield first with and then without a floor. And you can see and hear the difference. And here are shots without the floor at 5 and 7 miles per hour. And this is the floor versus no floor data comparison. And two things to note. With no wind, the results are within the margin of error, so effectively the same. And that's interesting because I would have expected the floor to show some benefit just from reflecting heat back upward toward the pot. And theoretically it must to some extent, but there does not appear to be enough heat redirected to save a measurable amount of fuel. And second, as soon as there is even the slightest of breezes, no floor shows more efficient than floor. So here's the SimmerShield without floor, side by side with the Ocelot Mini on low. And as with the Optimus, the efficiency leader goes back and forth between the two screens depending on the wind speed. But something else was bugging me about the results. Remember how with the Ocelot Mini on medium flame, sort of a dinosaur back appeared in the graph? And it isn't as pronounced, but it's already starting to show with the SimmerShield on low. Now, I had speculated that this hump was the result of an oxygenation problem. With the more open design of the Ocelot Mini, it doesn't show until you turn the flame up. The SimmerShield's more encapsulated design, however, seems to be showing the beginnings of this effect even at a low flame. And that led me to wonder if the Simmer's performance might get better with something even lower than low. An ultra-low flame, if you will. Now, on their website, SimmerShield takes care to describe the just right flame setting. Notably, the flame sound should be very quiet. And that probably means the standardized low that I've been using for all of my testing is a bit too high by Simmer's standards. Well, I didn't have a fourth MSR low down, but I do have a spare BRS stove. So, I used the duplicate stove mounted on my high standard and set the burner's valve to a new Simmer-like level. And this setup can now be maintained as a separate ultra-low standard. And this is what low looks and sounds like on a BRS, followed by the new, much quieter ultra-low. And for a baseline, I ran a bare BRS on ultra-low and compared it to the results for low. And when there's no wind at all, you can indeed push the fuel use down even further. But with even the gentle push of a 1 mile per hour waft, what little flame still reached the pot was unable to bring my water to temperature. And after burning 16 grams of fuel over more than half an hour, it became clear the thermometer wouldn't budge past 195, so I aborted the test. Ensconced in titanium protection, however, it's a somewhat different story. When testing the SimmerShield with a more Simmer-like flame, I did put the floor back on since that's the recommended method. And looking for that turnover point, I put the ultra-low and low performance side by side. The new ultra-low saves fuel up to 2 miles per hour. At 3 miles per hour, the efficiency was essentially identical. I'm calling that the turnover point, and you'll see why when you're looking at the time graph for these same results. At 3 miles per hour, it took an ultra-low burn over 21 minutes to boil. With a low flame, it took only 9 minutes 22 seconds. If I could save about 12 minutes while waiting for my dinner for no additional fuel, that's when I'm switching up to the next flame level. So here then is an efficiency profile for the SimmerShield, where I start by using the floor and then take it off when switching to low. And I did try it on medium, but it was still worse than low even at 7 miles per hour, where it took over 18 grams of fuel to boil. So it appears the SimmerShield is aptly named. It prefers to simmer when the wind permits, and probably doesn't breathe well enough to benefit from a medium flame even when the airflow is fast. Now, of course, I had to go back and run the Ocelot Mini through ultra-low as well. It turns out it turns over at the same 3 mile per hour threshold. So that gives the Mini an efficiency profile that looks like this. When the air movement is slight, set to simmer. You'll wait longer but save fuel. As the breeze becomes too stiff to easily use a lighter, turn your stove up a bit. And when the wind starts blowing loose items down the trail, turn it up again. The Mini's more open design seems to breathe well enough to facilitate the use of a medium flame at the fast end of the graph. And so finally, here are the side-by-side efficiency profiles of both the SimmerShield and the Ocelot Mini. And this is my attempt to show a best you can do look at each windscreen by comparing the most efficient way to use them for every speed tested. So recall that the bare BRS on ultra low used 5 grams of fuel per boil at 0 miles per hour. Well, the SimmerShield was the only screen I tested that showed a statistically significant improvement with no wind. With an unscreened stove on a still day, you can get 22 boils from a 110 gram canister. Put this thing on and you'll get one extra hot meal out of one of these. At all the ultra low speeds, this SimmerShield came out at least slightly ahead. Its encompassing design may help to cradle heat around the pot. Once the wind picks up, however, the Ocelot Mini takes the lead, and its ability to feed a medium flame appears to have an increasing advantage the faster the wind blows. From 3 miles per hour on, you get one extra boil from a small can by using the Mini instead. It depends on the speed, but at 4 miles per hour, the Mini can save you about 17 grams over the 10 or so boils you'll get out of one of these. And that's enough to cover the 12.5 gram weight advantage that the SimmerShield with no floor has. But at other speeds, the Mini can fall a few grams short. As far as the pros and cons of its design features, the SimmerShield attaching to the pot itself makes it more specific to the containers that you can use. But it also makes it less specific to the kind of stove you'll need. The shield wall weighs a scant 11.32 grams, with the floor adding another 3.18 grams. It's easily the lightest option tested whether you use the floor or not. It is a bit more fragile than the Mini and more fiddly to use. You have to slide the thing off of a hot pot to eat, and if you're not careful you can bend some of the tabs at the top. It also makes it a little tricky to see if your pot's centered on the burner. None of these are a deal breaker in my opinion. It doesn't take that long to get used to it. It also stays on securely even against the 7 mile per hour wind. Remember from part 1 that a wider vessel had the ability to capture more of the flame and could therefore be a more fuel efficient way to go. But a wide and flat aspect ratio ends up weighing more for the same water volume. The Tox 550 was the ultralight champ, and the Tox D118 Bull was kind of a sweet spot between increased efficiency and added weight. From part 2, the introduction of wind gave things a twist when the Bull's greater efficiency actually dropped off at the faster speeds. Well, I really wanted to see how that dynamic played out with a windscreen in place. As it turns out, Flatcat makes an Ocelot Max for larger sized pots. So the Max fits snugly on an MSR Pocket Rocket Deluxe. It is 4.8 inches in diameter and was designed for pots that are 4.75 inches and larger. It was actually made to be used with vessels that are wider than itself, where the design creates enough of a gap to allow airflow. My D118 bowl is 118 millimeters wide, or about 4.65 inches. So that leaves about a 2 millimeter inside gap all the way around. The instructions say that at less than 2 miles per hour, it's more efficient to leave the windscreen off. But at higher wind speeds, increase the burn rate to help with fuel efficiency, something that we've seen is true with other models already. First, I ran the Ocelot Max and Pocket Rocket Deluxe combination through on low. No dinosaur back, so I assume the oxygen supply is adequate. Then I used a medium flame and backed my way down from 7 miles per hour until I found the turnover at 2 miles per hour. At higher speeds, medium was substantially more efficient. So that gave me an efficiency profile for the Max system that looks like this. And here's what the Max looks like at 2 miles per hour on low, and then at 5 and 7 miles per hour on medium. So because my ultra low is set directly through a BRS stove, there's no way for me to accurately reproduce that flow rate with the MSR, so I couldn't try it out here. And based on what we've seen so far though, I'm definitely willing to predict that it would help some, at least at 0 miles per hour and maybe at 1 mile per hour. And here's what the efficiency profile for a bare Pocket Rocket Deluxe looks like compared to what you get by adding an Ocelot Max. As suggested by the instruction sheet, it's ever so slightly more efficient to leave the windscreen off when there is no wind to screen. But as soon as you start to move that air, the Max makes better, even at 1 mile per hour. At 2 miles per hour, a plain rocket needs a medium flame, but the Max lets you keep low riding for a little longer. By 3 miles per hour, the screenless stove has to be set on high, and the Max lets you keep it at medium all the way up. And at 5 miles per hour, even the famously wind-resistant Pocket Rocket Deluxe is tapping out. It now takes twice as much fuel to boil, meaning you'll only get half as many meals out of a canister without the windscreen. You'll get 2 extra boils out of a small can at 3 miles per hour and 3 extra boils at 4 miles per hour. In terms of being worth its weight in fuel savings, the answer for the Max system seems to be yes. At 4 miles per hour, you'll save 3.19 grams of fuel per boil, and you can get over 12 boils per can. And that's just over 38 grams of saving for a device that weighs only 30.41 grams. And at 5 miles per hour, if your trip requires just 6 boils, you'll need to bring a second canister or a bigger one. The medium-sized fuel can is 160 grams more than a small one. And of course, at the highest wind speeds, you're not even talking about weight anymore, but the ability to continue using your stove in those conditions. And then lastly, let's do a side-by-side of the efficiency profiles for both Ocelots, Mini and Max. Bear in mind that this isn't just a windscreen comparison. These are actually 3-part systems that differ in every component. The Ocelot Mini pairs with a BRS stove and a Toaks 550 pot, and the Ocelot Max fits on a Pocket Rocket Deluxe and was used with the D118 bolt. So when there was no air movement, the Mini system seems to use slightly less fuel. Remember though that because of my setup I didn't test the Max with an ultra low flame. As soon as any wind appears, however, the Max system starts using less fuel and the advantage grows as the speed increases. Again, from part 1 we saw that as vessels got wider, less and less fuel was required. A bigger pot bottom captures more of the flame and wastes less heat. And when wind was introduced in part 2, something interesting happened. There was actually a turnover at 5 miles per hour where the bowl suddenly becomes less efficient than a narrower pot. And I suggested at the time this may have something to do with the volumetric inefficiency of a flatter shaped vessel. There's more surface area to be cooled by a strong wind with a bowl than with a pot. With a windscreen though, it looks like this effect can be protected against well enough to return a bowl-based system to efficiency supremacy. And this is all it takes. Virtually none of the sides of the bowl are shielded from the wind. Just protect the flame so that it can bathe this wider area in heat, and you'll do better than a pot, even one that's deeply ensconced. I like big bottoms and I cannot lie. In terms of weight efficiency, ultralight designs can indeed be worth their weight, and that's in comparison to a bare stove. The last trade-off to consider is whether to go with a pot-based windscreen or the bowl. Remember, it's not just the windscreen, it's a system. An Ocelot Mini weighs 23.86 grams. It works with a BRS stove that weighs 24 grams and uses the Toaks 550 pot for another 59. And that's a system weight of just shy of 107 grams. The Ocelot Max weighs only about 6.5 grams more than the Mini, but it also uses the MSR stove at 80.1 grams and a bowl that weighs 83.2 grams. This system weight is now over 193 grams. And that's a total difference of 86.85 grams. So when looking at the fuel weight savings of switching from the Mini system to a Max one, this is the number to beat. It turns out the solo hiker using a small gas canister probably isn't going to get there. Even in this sweet spot, the fuel savings are only about 21 to 28 grams for the number of boils you'd get. The extra system weight could be worth it on longer trips though, or where the number of boils needed gets high enough to require extra canisters, like maybe with larger groups. Okay, just one more concept to discuss. The idea of a wind-resistant stove being further protected by adding a windscreen got me thinking about tiered systems. Yes, you could do something like this where you add a freestanding wall around your stove screen combo. Be careful about arrangements that trap the fuel inside. If you overheat the canister itself, there could be the risk of an explosion. But this just adds further weight and bulk to your system. So just briefly, I played around a little bit with the wind blocking effects of some common obstacles you might already be carrying or be able to find around your campsite. To do this, I set up a couple of box fans to create a wider artificial wind, and then I used my wind meter to find a spot that was at about 10 miles per hour. And if you're wondering why I didn't do testing beyond 7 miles per hour, it's because of this idea, and also because it becomes exponentially more work to run every possible combination at several more speeds, but mostly because of this idea. When it's that windy, I'm not going to rely solely on an attachable windscreen, however cleverly it's designed, and just leave the stove out in the open. I'm going to do what I think a lot of you would do too. Put something in front of it to help block some of that exposure. So to start, I put a water bottle on the field and measured the wind speed behind it. And even something as small and simple as this was able to attenuate about 3.5 miles per hour of wind, bringing that 10 miles per hour down into the 6 to 7 range. And that took things from well off this chart back into the realm of what's still quite doable. What about a tree? Even a pretty small one can get you under 5 miles per hour, cutting the wind in more than half. And as far as the distance of my wind meter from the obstacle, the wide-angle lens makes it look like a foot when it was really more like a hand. I left room for fire safety, as the aforementioned turbulence can cause flashes of flame to dance out occasionally in various directions. And then lastly, I tried it with a backpack. Careful about lighting those straps on fire. And this brought 10 miles per hour wind down closer to 4. Well, that can make even a very blustery day quite manageable for windscreens like those tested. So for those that might argue that you could just use the backpack for blocking and skip a windscreen entirely, bear in mind that a BRS stove isn't even usable at 4 miles per hour. So in that circumstance, a backpack really wouldn't help you at all. He says, I'll use an MSR. And true, you will be able to bring a pot to boil on a bare Pocket Rocket Deluxe at 4 miles per hour. But remember that a BRS and an Ocelot Mini combined weigh less than the PRD, and they're more efficient at those speeds. So you'd still be better off with a windscreen option. In strong winds, an obstacle doesn't seem practical as a windscreen replacement. Rather, it's an accessory to help extend the range of your screen even further and improve fuel efficiency a bit more than just a system left out in the open. Indeed, I would like to measure wind speeds inside the vestibule area of a tent, but I don't have a way to fairly test something like that with my current equipment. Weather permitting, someday I'll do some field tests and report back. One final note, at backpack sizes, the Reynolds number is up over 100,000, so expect turbulence in the lee. And depending on the type of windscreen you're using, you might want to adjust accordingly. For designs like the Optimus, it might actually work better behind a backpack if you turn the open side toward the obstacle, as vortices can bring gusts in from what would otherwise be downwind. Okay, I think that brings us to the summary. All the models tested were capable of providing meaningful fuel efficiency improvements depending on the wind speed. Heavier windscreens may not be worth their weight in fuel savings, but ultralight models can be. There is a learning curve, though, in how to operate screen stoves most efficiently. An ultra-efficient, ultra-low flame becomes more practical when the flame is protected, but be prepared to increase the level to keep up with the airflow. If the flame is being battered about and keeps sputtering in the wind, you may want to turn it up. Overdoing it is also an issue. The increased protection from wind can also mean decreased access to oxygen, so too much flame will waste energy with incomplete combustion. A funny smell while burning and soot on the bottom of the pot are evidence that you should adjust the burner. And as always, it's difficult to pick a single winner because there are competing criteria and no one windscreen is best at everything. SimmerShield was the lightest option tested when not using the floor or any of the included accessories. Just the shield wall by itself on a Tox 550 over a BRS stove gives the system weight of 94.32 grams. If you do use the entire SimmerShield system as supplied with their pot and cozy, it ends up being 141.51 grams. In terms of fuel efficiency, it was the only windscreen to improve performance slightly when there was no wind, and it had the best 1 mile per hour performance when used on ultra low. From 2 miles per hour and beyond, the most fuel efficient setup was the Ocelot Max using a Tox D118 bowl on a Pocket Rocket Deluxe. The wider vessel combined with an inherently wind-resistant stove and a cleverly designed windscreen gave that system the best results when the wind was more than just a faint breeze. Those heavier parts, however, caused this to be the weightiest system at 193.71 grams all in. For me, that leaves the Ocelot Mini as the sweet spot between the two extremes. At speeds above 2 miles per hour, it beats the SimmerShield's fuel efficiency while weighing only 12.5 grams more. And while I do love the idea of a couple extra boils from the Max system, it's hard to beat the appeal of a smaller, lighter kit that packs within itself. And admittedly, it's a situationally dependent calculation though. Fuel savings add up while equipment weight stays the same. If going on a 2-week trek and boiling for a group, I might end up taking the Max. These conclusions are just my personal take. The data is there to help you make more informed decisions based on your own circumstances. As always, I very much appreciate your time, and thanks for watching.